How's it going, everybody? This is Alex Andronica on Atlanta's first forensic radio. Today we'll be talking about the cross-section of the human skin. After looking at these images the past couple of days, I've really become more educated on the components and their functions in the human skin. It is a lot more complicated than from what we see on the outside. Definitely very interesting. I'll be talking about the epidermis, sebaceous glands, sweat glands, papilla, and the capillary to start it off today. With the epidermis, it's the outer layer of cells covering an organism. The sebaceous gland, a small gland in the skin which secretes a lubricating oily matter known as sebum into the hair follicles to lubricate the skin and hair. Sweat glands, a small gland that secretes a sweat situated in the dermis of the skin. Such glands are found over most of the body and have a simple coiled tubular structure. The papilla, a small rounded protuberance on a part of organ of the body. Capillary, any of the fine branching blood vessels that form a network between the arterioles and venules. That's quite interesting. The three layers of the cross-section of human skin, you have the epidermis, which contain the hair, the very top layer of the skin, the pores, and also part of the upper layer of the muscle. Next, you have the dermis, which is the sebaceous glands, the hair erector muscle, and part of the sweat gland. Next, you'd have the third layer is the subcutaneous fatty tissue, which contains the blood vessels known as the papilla. Known as the capillary. Now we'll get talking about we'll get into depth on topics going into the cross-section of the human skin. First topic, we have the function of the hair and its parts. Hair is a simple structure but has important functions in social functioning. Hair is made of a tough protein called keratin. A hair follicle anchors each hair into the skin. The hair bulb forms the base of the hair follicle. In the hair bulb, living cells divide and grow to build the hair shaft. Blood vessels nourish the cells in the hair bulb and deliver hormones that modify hair growth and structure at different times of life. Hair growth occurs in cycles consisting of 3 phases. Now we're on to the life cycle of the hair, which is another topic, which is the anagen, the growth phase. Most hair is growing at any given time. Each hair spends several years in this phase. Next to the catagen, the transitional phase. Over a few weeks, hair growth slows and the hair follicle shrinks. To the final stage, the telogen, the resting phase. Over months, hair growth stops and the old hair detaches from the hair follicle. A new hair begins the growth phase, pushing the old hair out. Hair grows at different rates in different people. The average rate is around 1/2 inch per month. Hair color is created by pigment cells producing melanin in the hair follicle. With aging, pigment cells die and hair turns gray. Well, that's interesting. Now on to the human hair versus the non-human hair. Hair is an outgrowth of protein found only on mammals. The primary growth of hair fiber is keratin, as we know. Keratins are proteins, polymers of amino acids. It projects from the epidermis through it grows from hair follicles deep in the dermis. Now, moving on to fur, known as the non human version of hair. Fur refers to the body hair of non-human animals as the pelage. Animals without fur may be referred to as hairless or naked at certain stages of life. Hair is absent in some of these species. The definition of fur, you would say it would be known as the thick coat of soft hair covering the skin of a non-human mammal, such as a fox or a beaver. It tends to grow in a more synchronized manner and stops at a certain length. It includes a double composition, and it is coarse and short. For hair, a growth of such filaments as the forming the coat of a human. It tends to grow independently and does not stop growing compared to the fur, which does stop at a certain length. It is a single composition or texture, and it is soft and long. Next topic, we'll be talking about ethnic group differences. While no two heads of hair are the same, there are three main classifications of hair type based on race: Asian hair, Afro hair, and Caucasian hair. There will of course be small regional differences, but in general there are defined similarities among each ethnic group. Whether it is a question of the hair's density, speed of growth, or the shape of the hair follicle in the scalp, we can consider that each of the ethnic types mentioned above has its own identity. All hair, be straight, wavy, or frizzy, is essentially made of the same thing. Each strand consists of three layers: the cuticle, cortex, medulla, and a protein called keratin is the hair's main component. However, the shape of the follicle is what determines the hair's shape. Asian hair grows from a round hair follicle, while the Afro hair sprouts from an oval one. Caucasian hair follicles vary. Being a dead material, the hair subsequently keeps the original shape. Asian hair is usually bone straight, Afro is usually spiral, like fashion, and Caucasian hair can be anything in between. Now, on hair growths, talking about in the ethnic groups and differences and stuff, they rate between hair races. Caucasian hair grows at a rate of 1.2 centimeters a month and has the greatest density of all three hair types. Blondes have about 146,000 hairs on their head. Black-haired beauties, about 110,000 hairs. Brunettes, 100,000. And redheads, roughly around 86,000. Afro hair is predominantly black, and healthy person possesses about 50,000 to 100,000 hair on their head, but they have the slowest growth rate of about 0.9 centimeters per month. Asian hair, the most dominant hair type in the world, outspeeds the rest with growth rate of 1.3 centimeters per month. And despite an estimated 80,000 to 140,000 scalp hairs, it usually has the least density. Wow. That's a lot of information comparing the different types of hair in the ethnic groups and stuff. It's pretty interesting, as you see. Now moving on to our next topic would be the bodily region differences of hair. So the body area determination. The body area from which a hair originated can be determined by general morphology. Length, shape, size, color, stiffness, curliness, and microscopic appearance all contribute to the determination of body area. The pigmentation and medullary appearance also influence body area identification. Hairs that exhibit microscopic characteristics shared by different anatomical areas are often referred to as body hairs. These include hairs found on the upper legs, the lower abdomen, and back. Because there is a wide range of interpersonal variation in head and pubic hairs, the majority of work in forensic has been in comparing and differentiating hairs from the head and pubic regions. The head hairs. They are usually the longest hairs of the human body. They are characterized as having a uniform diameter and often a cut tip. Head hairs can appear uncut with tapered tips, but are more often cut with scissors, razors, or clippers. In general, these hairs are subject to more alteration than hairs from the body areas. The alterations to the natural appearance of hair include use of hair dyes, rinses, permanents, frosts, and other chemical applications. Environmental alterations can result from exposure to excessive sunlight, wind, dryness, and other conditions. Because these hairs can be affected by a number of environmental and chemical conditions, it is recommended that head hair samples be obtained as soon as possible from suspects and victims of crime. Head hair samples obtained years after a crime are generally not suitable for meaningful comparison purposes. Now comparing the pubic hairs. Pubic hairs are also routinely compared in a forensic laboratory. As with head hairs, considerable variation exists between individuals in the population. Pubic hairs are not subject to as much change as head hairs over time, and because of this, a sample taken a year or more after a crime may still be suitable for meaningful comparison purposes. It is recommended that a known pubic hair sample be obtained as soon as possible after a crime should contain at least 25 full-length hairs taken from different areas of the pubic region. Pubic hairs are generally coarse and wiry in appearance. They exhibit considerable diameter variation or buckling and often have a continuous to discontinuous medulla. While tapered tips are common, these hairs may also be abraded or cut. Here we also have facial hairs and other body area hairs. Facial hairs are more commonly called beard hairs or mustache hairs, as we all know, grown on the face. It's quite obvious. These hairs are coarse in appearance and can have a triangular cross-section. Heavy shouldering or tufts in the hair are observed under magnification. Other characteristics include a wide medulla and a razor-cut tip. Other hairs are known as chest hairs, eye hairs, nose hairs, which are also routinely compared. As you can see, there's all sorts of hair growing on the body. It's crazy how different they are from each other, but it's quite neat. Now on to the fun part, a crime scene. We were just found out about this crime scene a few days ago. We went into depth on it. It's known as the murder of Leanne Tiernan. But before we get into it, I want to say that the hair evidence is one of the most common types of evidence encountered in criminal investigations. During the course of the normal hair growth cycle, hairs are readily lost from individuals, and these hairs may be transferred during the course of a criminal activity. So moving into the case, this was in August of 2001. A man walking his dog in Lindley Woods near Otley in West Yorkshire found the body of a 16-year-old Leanne Tiernan buried in a shallow grave. This was about 10 miles from her home in Landseer Mount Bramley, Leeds. She had last been seen walking home from a Christmas shopping trip with her best friend in November 2000 when she disappeared. How she was found. She had a black plastic bag over her head, held in place with a dog collar with a scarf and cable tied around her neck, and cable ties holding her wrists together. Her murderer had then wrapped her body in green plastic bin liners tied with twine. This is the largest search in West Yorkshire. The police searched around 800 houses and 15,000 gardens, outbuildings, and sheds on her route from the bus stop to her house, as well as searches of a 3-mile stretch of canal. drain shafts, or more land. Wow, that's a lot. The length of the time since her death. The pathologist examining her body said that it had not been there since November. She had been strangled and her body stored at low temperatures in the intervening time. Police tracked down suppliers of the dog collar and found that a man from Bramley had bought several similar to the one found around Leanne Tiernan's neck. His name was John Taylor, and he was a poacher who had been seen around the woods where the body was found. The twine was an unusual kind used for the rabbit netting, and was tracked down to a supplier in Devon, which had only produced one batch. It matched twine found in John Taylor's home. Some of the cable ties used on Leanne Tiernan's were of a type used almost exclusively by the Royal Mail, the patent company of John Taylor's employer, Parcel Force. When the police searched John Taylor's house, they found more of the cable ties in one of the dog collars. Wow. Now moving on to the DNA examination part of the crime. Police searched the woods and recovered around 400 items, including cans and magazines, and forensic scientists compared DNA samples from these, the duvet cover, and the bin bags with the samples from the friend's family residence on the council estate where Leanne lived, and known sex offenders. The scarf tied around Leanne Tiernan's neck had a few hairs caught in the knot. Unfortunately, there was not sufficient DNA in the roots for standard DNA profiling. However, the scientists found very small amount of DNA in the hair shaft and used mitochondrial DNA testing to match it to John Taylor. There were dog hairs on Leanne Tiernan's body, and scientists in Texas produced a partial dog DNA profile. This was the first time a British murder investigation has used dog DNA profiling. However, John Taylor's dog had died, so this could not be used in evidence. Forensic scientists found a strand of pink carpet fiber on her clothes with a specific pattern of dye. Though John Taylor had destroyed the carpet by burning it, police found strands around a nail that matched the fiber of her jumper. Searching around the floorboards, police found bloodstains that the forensic scientists identified as belonging to Leanne Tiernan. The arrest. John Taylor was arrested in October 2001 and sentenced to 2 life sentences in July 2002. In February 2003, he was convicted of 2 rapes, based on DNA evidence, and given 2 additional life sentences. It's crazy what you can find from the hair samples, and it can lead you to finding the criminal in this death. It's quite fascinating. But I hope you enjoyed the cross-section of the human skin and all about the hair. Thanks for tuning in with us here on the first Forensics Talk Radio. Thanks again. This is Alex Andronica. Sleep tight, Atlanta.